solve the triangle. So the last page is just examples of exactly these kinds of triangles. So basically, I mean, you can use the law of cosines to figure out everything in these cases, but because the law of cosines, at least the formula itself, is slightly more complicated. Typically, the way you do these is you use the law of cosines to figure out one thing first, and then once you have that, the other things can be, the other angle can be, and the other sides can be solved in different ways. So either using the law of sines or just some other calculations. So, but I mean, you don't have to do it this way. You can just use the law of cosines for everything. It's just more calculations that way. Okay, so let's do the calculation, right? So what do we have here? So angle B is 73 degrees. Side A is 12, and side C is 22. Right, so I have SAS, and then so the other things are known, right? So, so I can figure out side B using the law of cosines, right? So again, which of the three versions you use depends on which angle you're focusing on, right? So here we're focusing on angle B because that's the one we know, right? So we want to use the law of cosines where angle B with angle B, so that's this one here. So B squared is the A squared plus C squared minus 2AC cosine B. So the way you remember is the thing squared here is the same as the angle, right? So this is side B, this is angle B, side A, angle A, side C, angle C, right? So we want to relate side B and angle B. So the formula is B squared is equal to A squared plus C squared minus 2AC cosine B, right? So again, the angle here should correspond to the side here. Then the other two sides are just coming from the Pythagorean theorem. And then the two sides here is always the same as the two sides here. Okay, so now we're just plugging in the numbers, right? So you get B squared is equal to 12 squared plus 22 squared minus 2 times 12 times 22 times cosine of 73 degrees. So B squared is equal to 12 squared plus 22 squared minus 2 times 12 times 22 times cosine 73. So that's about 4073.63. So B, so now you square root both sides to get B. But again, it's better not to round to avoid rounding as much as possible because that introduces rounding error. Okay, so let me just use the previous calculation. So I get B is about 21.8 rounded up. Okay, so now I know side B. I know this side. And then again, I mean, you can continue using the law of cosines, but it's easier to now switch to the law of sines, right? So I know B completely. So now if I want to get angle A, I can switch to the law of sines, right? So sine A over A is equal to sine B over B, right? So what do I get? Sine A over 12 is equal to sine 73 over psi B, which is 21.8. So what do I get? Sine A is equal to, right, so the 12 multiplies over. So what do I get? 12 times sine 73 divided by 21.8. So sine A is 0.5264. Which again is okay, right? Because sine of the angle should be smaller than 1. But that's not actually the angle, right? So to actually get the angle, I have to do the inverse sine. So what is A? So inverse sine of this thing is about 31.8 degrees. Okay, so now we have angle A, and then now we know two of the angles, right? So angle C is just 180 minus 73 minus 31.8. So angle C is equal to, so what is this? 180 minus 73 minus 31.8, which is 75.2. Okay, so this is the SAS triangle. So again, you can figure out one of the sides using the law of cosines, but once you get that side, you can switch to using the law of sines to figure out the angle. So any questions on using the law of cosines? Okay, so let's continue on to the last example. Here we have the SSS triangle where all three sides are known, but all the angles are unknown, right? So A is 14, B is 24, and C is 33. So again, we can start by using the law of cosines, but once we have that, we can switch to the law of sines. So here we don't know any of the three angles. So it doesn't matter which angle you're trying to solve for. You can choose either A, B, or C. And then you set up the correct law of cosines for that angle. So let's do that, right? So let's say we're doing angle A. Right, so for angle A, right, so if you remember the law of cosines, the angle relates to the side, right? So this should be A squared. And then you have the other two sides. So B squared plus C squared minus 2BC times cosine of the angle, which is A. And then so now let's plug in the information, right? So 14 squared is equal to 24 squared plus 33 squared minus 2 times 24 times 33 times cosine of A so let's calculate, or let's do some of the calculations. So you want to be careful here, right? So how does this calculate? So 14 squared. So calculate each of the individual pieces first, right? So 14 squared is 196. What is 24 squared? Is 576. What is 33 squared? Is 1089. And then 2 times 4 times 33. 2 times 24 times 33 is 1584. So this is where you want to be careful, right? So you can combine these two things together because they're just by themselves, but you cannot subtract this, right? Because it's a coefficient for cosine A, right? So we just add these two things together. So 576 plus 1089. What do we got? 1665. And then minus right, so you should think of this as a coefficient. So I need to subtract the 1665 over. Right, so what am I doing? Right, so I'm minus 1665 minus 1665. Right, so what is that? 196 minus 1665 is negative 1469 is equal to minus 1584 cosine A. So that means that cosine A is equal to negative 1469 over negative 1584, right? Because I have to divide by the coefficient. And so what does this get me? Negative 1584. So that's about 0.9274. So, but that's cosine of the angle, and it's smaller than 1, so that's okay. All right, so now I have to do the inverse cosine. So what is this? Inverse cosine. Gives me an angle of about 22 degrees. Okay, so angle A is 22 degrees. And then now we need to figure out angles B and C. Right, so I'm running out of space, so let's just do it over here, right? So now we can switch to the law of sines again, right? So sine B over side B is equal to sine A over side A, right? So sine B over 24 is equal to sine 22 degrees over A, which is 14. So again, I multiply by 24. So that means that sine B is equal to 24 times sine. So again, I'm going to avoid rounding error by not using 22, but the previous calculation divided by 14. So that's 0.6413. So we're going to have to use the inverse sign now. So B is the inverse sign of 0.6413. So what do I get? Inverse sign. Six, 413. So I get about 39.9 degrees. So that's angle B. And then finally, angle C. I can just do the 180 degrees thing again. Minus 22 minus 39.9. So angle C is equal to it's about 118.1 degrees. Okay, so I get angles A, B, and C in this way. Again, you can check that C is biggest, then B, then A. So in terms of the angles, angle C should be biggest, then angle B, then angle A. Okay, so that's the law of cosines. Are there any questions on the law of cosines? Okay, so if there are no questions, so this is the last material that we're going to cover in this class. So I'm going to post the problem set for these two sections in a little bit in my open math, and I'm going to send out an announcement regarding that. So just be on the lookout for that. And if there are no other questions, I'm going to end the lecture here.
All right, sounds good. Happy Teacher's Week.
It was a nice experience with you, sir.
Right. Thank you. And yeah, if you have any other questions throughout this week, just let me know.
Okay, will do. Thank you.
Have a good day. Stay safe.